Since the inception of manufacturing, factory owners have looked for ways to increase productivity and lower cost. This resulted in many of said factory owners looking to automation to help their bottom line. So what is automation? According to the Merriam-Webster Dictionary, automation is the automatically controlled operation of an apparatus, process, or system by mechanical or electronic devices that take the place of human labor. What does that really mean? If you walk inside a modern manufacturing plant, you might see something like this. Robots and other automated machinery that can run typically without the need for human involvement. Automation results in better efficiency. Let's face it, humans make mistakes, and they're not always very consistent. Automation practically eliminates error, increases productivity, and allows for better monitoring and control of the manufacturing process. Automation also allows for a certain task to be replicated over and over again. Robotic automation started showing up in factories in the 1970s, and as time has passed, the technology has become even more sophisticated. As it advances even further, it is not outside the realm of possibility that one day manufacturing facilities could run without the need for humans on site at all.
Volvo Cars and Uber now present Volvo Cars' first autonomous drive-ready production vehicle, the next step in the strategic collaboration between both companies. The design is based on the refreshed Volvo XC90, with extra technology added to help support a safe introduction of autonomous driving. The car's development is a part of Volvo Cars' commercial agreement with Uber for the delivery of autonomous drive-capable base cars. An important feature of the autonomous drive-ready car is the inclusion of backup systems for functions such as steering, braking, and the 12-volt battery. This means that if any primary system would fail for some reason, the backup safety systems are designed to act immediately to bring the car to a stop. Beyond this, an arrangement of ultrasonic sensors and cameras around the car create a 360-degree near-field perception capability designed to help the car safely monitor its close surroundings. The cameras are fitted with individual cleaning nozzles to maintain visibility while driving. A new vehicle motion control function translates a computer-calculated path into car movement. Volvo Cars' first autonomous drive-ready production vehicle will be supplied to Uber as a base vehicle for Uber to modify with its own technology and systems, including its autonomous driving computer and roof box sensor kit that can enable the car to drive autonomously. Volvo Cars is developing a similar base vehicle concept for its future autonomous drive vehicles.
What is CAD? CAD stands for Computer-Aided Design. What can you make using computer-aided design? Cars, houses, jewelry, engines, cool stuff, flip-flops, models, and pretty much anything. How does it work, you ask? You can design on a computer and send it to a 3D printer. Or you can use a 3D scanner to scan a real object, then send it to a 3D printer. Why don't engineers just use a pencil and paper anymore, you ask? It is easier to share your ideas using the internet. You can design with more accuracy. It is also easier to change a design using a computer than using a pencil and paper. You can get a job at Google and this could be your office. Any questions?
This production centers upon CAM, or Computer-Aided Manufacturing. Computer-Aided Manufacturing, or CAM, utilizes the part geometry defined by the CAD drawing. That geometry is imported into the CAM software, which allows the engineer to select cutting paths and other process parameters for manufacturing a specific part. CAM uses databases that are specific to the material, tools, and the work center to be used in the actual machining process. The programmer identifies the manufacturing process information utilizing the CAM software such as feeds, speeds, and depths of cut. This information is run through the post-processor, which translates the information into a CNC program that the work center can utilize directly. The CAM system can also simulate a production cycle of the part, which includes a visual representation of the machine, tooling, and workpiece motion. The software can provide an estimated cycle time that can be used for quoting. It will also alert the engineer of any tool collisions, constraints, or interference that may occur.
If you've ever taken shop class in high school or watched an episode of How It's Made, you probably have some idea how lathes and other metalworking machines function. As technology and computers have improved over the years, a new high-precision computer-controlled manufacturing technique called CNC machining has spawned. CNC machines, or computer numerically controlled machines, are electromechanical devices that can manipulate tools around a varying number of axes, usually 3 or 5, with high precision per instruction from a computer program. CNC machining is one of two ways that engineers, machinists, or makers can generate a physical part from a computer design file, with the other being 3D printing, known as additive manufacturing. The contrast between these two techniques is stark. CNC machining, like other machining processes, is a subtractive process, where material is removed from a stock. 3D printing, on the other hand, is an additive process, essentially functioning in reverse. The first CNC machines were developed in the 1940s and 50s and relied primarily on a data storage technique known as punched tape. The code to control the machines would be manually punched into a data card and fed into a system that would then interpret the data. Needless to say, these early machines were rudimentary and their functionality was limited. CNC machining technologies rapidly grew as technological capability only accelerated in the late 20th century, which brings us to how modern CNC machines work. As mentioned before, machining is a way to transform a stock piece of material such as aluminum, steel, or titanium into a finished product or part. CNC machines rely on digital instructions, specifically referred to as G-code. Before modern computer-aided manufacturing and computer-aided design programs such as Autodesk's Fusion 360 were around, machinists would manually write the G-code to control these machines. machines. CAM programs today allow you to take a 3D model and automatically generate G-code that will drive the machine with little input. When you compare the capabilities of automated CNC machining to the manual alternative like lathes and other machining techniques, you can start to see the benefits. CNC machines simply run faster at higher precision and accuracy while simultaneously allowing the transformation of a digital design into a physical part. Many designs or specific machining processes require the use of multiple tools to make cuts. One tool doesn't function universally. For this, machinists will often build digital tool libraries that interface with the physical CNC machine. These machines, often costing hundreds of thousands of dollars, can automatically switch tooling when directed by their digital instructions, allowing for them to become manufacturing workhorses. Basic CNC machining will move one or two axes, referred to as the x-axis and the y-axis. You'll often hear the terms 2.5-axis, 3-axis, and 5-axis CNC machines, which simply refer to the degrees of freedom a machine can make cuts in. A 3-axis machine will move in the x, y, and z-axis, whereas a 5-axis machine can move in these 3 axes along with 2 additional rotational axes. As you might be able to imagine, the possibilities of production with 5-axis machines are practically endless. 5-axis machines used to be relegated to high-precision work, but as they have become more affordable, they are quickly becoming standard in many shops. There are 3 conventional machining technologies that you need to understand to grasp the basics of how material is removed from stock in CNC machines. The first being drills. Drills work by spinning a drill bit and moving the bit into contact with a stationary stock. Next, we have lathes, which function in reverse to drilling. Lathes spin the block of material against a stationary drill bit or cutter to remove material in a circular or fluid path. The shape capabilities on lathes are more limited than other techniques, but modern technology does allow these machines to create things such as square holes or non-circular shapes. Lastly, the most common CNC machine type is referred to as a milling machine. Milling machines involve the use of rotary cutting tools to remove material from a stock piece. These machines function similar to drills, with their tooling capabilities encompassing much more variety. Almost any material can be used in CNC machines, from plastic to titanium. Different materials have different properties, so machinists and engineers will overcome their unique challenges by altering machining variables like tool selection, RPM, feed rate, and coolant flow, among an extensive variety of other factors. CNC machined parts are all around you. They hold together your car and perform vital functions aboard SpaceX rockets. CNC machining is arguably the only way to produce high-precision metal parts for engineering designs across the world. So, CNC machining is arguably the most significant manufacturing process of the 21st century, and its functionality drives technological advancement across the globe. It's a trade that is keeping up with the growth of technology, and machinists across the planet are changing the world with their CNC machining skills. Thanks for watching.
created using Powtoon.